Okay, so what I want to look at in this lesson is the idea of emission and absorption of light by elements. So emission and absorption. So we'll focus on emission first. So what does emission mean? So basically what it means is that a substance will give out light. And in this particular case, the substance that we're talking about are elements on the periodic table. So let's have a look. So when atoms of an element are supplied with energy or under certain conditions, they will emit light. So what we have here, what we're looking at in this image here, are different elements that are being heated up. Okay, so you can, if you put some of these elements, they're salts of the elements into a flame, what will happen is they will give off or emit characteristic light, or light that is actually characteristic of the element that's present. So what do we mean by that? Well, if we have a look here, at this, what we can see here is, so here we have, for example, we have potassium. So this flame here represents potassium being ignited. And what's happening is it's giving off an emission that's this particular color. And we can see that potassium, if we look at this table here, potassium gives off a characteristic lilac color. If we have a look here, so this is copper. And again, you can see it kind of gives off this bluey kind of green type of color as well. And that's indicative of copper being present. Sodium then, so this is sodium. Again, if you have salts that have sodium in them and you ignite them, for example, or you put them into a flame, what's going to happen is they'll give off a characteristic color that's yellow in color, like what we can see here. And then we just have this one then, lithium. So lithium, again, it gives off this kind of a deep red color. So what we can say is that elements, when they're given energy, some of them will give off a characteristic color, or they'll give off an emission of this characteristic color. Now, this fact as well is taken advantage of people who manufacture fireworks, for example, like what we see here. So the different colors that we get, so when you see fireworks, erupting in the sky, the different colors that are being emitted are they're generally salts of certain elements that are used. For example, strontium, when you use a salt of this, what will happen is it'll give off, as we can see, it'll give off this characteristic red emission as well. So again, we can use salts, for example, salts of certain elements are used in fireworks in order to get characteristic colors. So essentially what you can do is you can link the elements to the colors that they produce when energy is supplied to them. For example, in the form of, it can be in the form of electricity, or it can be in the form of a flame. If they're put into a fire, for example, or into a flame, they'll give off these characteristic colors. Now, what can also be done as well, so instead of the energy source being, for example, a flame, so instead of using a flame to provide energy to these elements and see what colors they produce, what we can do is we can actually use electricity to give energy to particular elements. So what we have here, so if we have a look at this here, so this here is what's known as a discharge tube. So discharge tube. And basically all it is you have a power source, and then you have these two electrodes on either side inside a hollowed out glass tube. And the tube, most of the air has been taken out of the tubes, and so therefore it's kept at a very, very low pressure. And what happens is that allows, when you put a gas of a particular element in here, what's going to happen is it's going to allow the movement of electrons. So electricity is going to be moving down through this, and then what will happen is the electrons will pass in this direction through the tube from the cathode to the anode. Now, so these electrons, which are charged particles, they're going to have a lot of energy. And when they come into contact with atoms, they're going to transfer that energy into the atoms. And essentially what they'll do is they'll provide energy to the atoms. And as we know, when certain elements are given enough energy, they will give off an emission, or they'll give out light, basically. So if you were to take, for example, just one element, if you take, for example, neon. So neon is a gas, it's one of the noble gases. And if you fill this container with neon, this discharge tube with neon gas, and then you pass a current through it, what's going to happen is the atoms of neon are going to take up the energy that is coming from the electricity, and what's going to happen is they're going to give off a characteristic color. So you'll normally see these neon lights, for example, you'll have a gas of neon, for example, that's in there, and what will happen is when it comes into contact with the electrons that are flowing through the discharge tube, they'll give off a characteristic glow. So they will, that's can be associated with neon lights. Also, as we see here, so if we take sodium, for example, sodium gives off, as we see here, gives off this characteristic yellow color. The same thing happens as well if we were to take a tube like this and we were to fill it up with, let's say, so we put sodium inside here. We fill this up with sodium and then we pass a current through it. What's going to happen is it's going to glow and give off a characteristic yellow color, and that's what we can see here in this picture. So these are sodium street lamps, and as you can see, they're giving off that characteristic yellow light, or yellow emission is coming through here. So essentially what you have here is you're going to have electricity passing through this glass tube, and it's going to excite the atoms of sodium, and those atoms of sodium will give off a characteristic yellow color. Now so I want to look at this apparatus here that we have. So the apparatus that we're looking at here is what's called a spectroscope. So spectroscope. Okay, and spectro relates to light or spectrum, and then scope is just something that you look down. So, and this is what they look like, and I'll explain like what they're all about. So basically what happens is with a light, so if we take, let's say, white light, so white light comes from the sun, and it contains all of the colors of light. So as you can see here, we see a rainbow, and we can see that we have all of these characteristic colors of light. Now, all of these characteristics of colors of light are actually contained inside white light that comes from the sun. You can't see white light, but what happens is, if you're to take that white light, like what we have here, and you are to pass that through a prism, what's going to happen is it's going to bend the different wavelengths of light, and it's going to split them up so that they can actually be seen. So that's what we can see here in a rainbow, for example. What's happening is the white light from the sun is passing through the sky, and the rain or the moisture, the rain droplets in the sky are acting like a prism, and what they're doing is they're actually splitting up the white light into its constituent different wavelengths of light, and we see these different wavelengths of light as different colors, as we can see here, the colors of the rainbow. Now the same thing, what we can do is we can do this in a lab, like if we take white light and we can use these lenses to produce parallel rays, so they're just rays that are parallel lines, and if you pass them then through a prism and you focus them then onto a surface, or onto a particular type of substance that will show up the different the wavelengths of light, what's going to happen is it'll spread out the wavelengths of light, and you'll be able to see all the different wavelengths that are present there. Now if you take this instrument like this, so what happens is, the light passes through and it produces a spectrum, and we can actually look at that from this side here. It produces this spectrum. Now if you were to pass, let's say, white light, if you were to pass white light through this through one of these spectroscopes, what's going to happen is you're going to get what's known as a continuous spectrum, and this here is a continuous spectrum. And what continuous means is that it contains all of the wavelengths of light in it. So this is what's known as a continuous spectrum. Continuous spectrum. And this continuous spectrum is contained within white light, and it'll look something like this. So you'll have the range of colors. Now, if we think about light, for example, we can think about light as a wave, like what you can see here. So you have waves. And what you have is you have this characteristic wavelength. Now, what happens is light is diffracted or bent at different angles depending on the wavelength. So because of that, what we're able to do then is we're able to separate all the light. So imagine this is your prism here, and this is your white light coming through. What's going to happen is it's going to pass through the prism, and it's going to bend, let's say, all the white light. It'll all come out at different angles. And then essentially what you're doing is you're shining it. So you might have, for example, this will be one band or one section on the so this here might be one section of light that's been bent in that direction. Let's say this might be another band of light that's bent here. You'll have another band of light that's bent here, and so on and so forth. And this is what it looks like here. This is what it actually looks like. So what's happening is these smaller wavelengths of light, when they go through a prism, they're diffracted or they're bent at a greater angle. And as you move across, and as the wavelength of light gets spread out, it's not diffracted as much through a prism, for example. And but what happens then is you get this splitting up of white light into its characteristic wavelengths that are all contained within it. So you have all of these different colors. And remember, this continuous spectrum comes from white light. So essentially light from the sun, for example, is white light. Now, an interesting thing starts to happen if you start to use, so remember we talked about our discharge tube here. So what you can do is you can actually fill up the discharge tube with a substance like neon or sodium or some other, or hydrogen, for example, and then you can pass electricity first. And what's going to happen is it then will produce light. Okay, it'll produce a source of light, and then you can use this. You can put in different elements into the discharge tube, as long as you can put them into gas form, and then the discharge tube acts as a source of light, and that's what we see here. So here we have a discharge. So here in this picture we have a discharge tube, something like this, and inside this there's going to be an element. A current is being passed through it. It's generating light like this. This light is passing through the spectroscope, and what we do is we look and see what's been produced. So remember, white light, it contains all the wavelengths. It'll produce a characteristic spectra or spectrum like this. But something really interesting happens when you use a discharge tube with individual particular elements. Remember, individual elements have their characteristic color. So for example, if you have a sodium lamp, it's going to give off this characteristic color of light. And then you pass this through a prism, and you split up the light that's present in here to see what that looks like. And what actually happens is you start to get these kind of things here. So I'll just bring over this here so we can kind of compare it to, I'll put it up here. So if we have a look here, what's happening is, so this here is what's known as a line spectrum. and this is a line spectrum for the element hydrogen. Now, if we think about it, if you look at the two of these, like what's the difference between the two of them? We can see here that this one here, this continuous spectrum, contains all the wavelengths of light. So you can see it's just a continuous spectrum the whole way, all the way across. It's all the different wavelengths of visible light is present here. Now, if we have a look here at this, what's happening is, and maybe we can actually, let's rotate this around. So rotate 90, rotate 90 again. So if we put it this way. So what we can see here is that hydrogen only seems to give off, so it gives off some of the red, for example, some of this color, some of this color, and some of this color. But it doesn't give all of the different, it doesn't give all the bands of color that are present. So what we can see here is that there's only certain wavelengths of light that are being emitted by atoms of hydrogen, like we can see here. So this is really useful because what this does is it enables us to, it's kind of like a fingerprint for particular elements. So we can take our element of hydrogen, we can make it into a gas and put it inside here in the discharge tube. We can pass electricity through it like this, and then we can pass that light through this spectroscope, and then it'll produce one of these line spectrums that we can then look at and examine. And we can use this then as a way, it's like a fingerprint for hydrogen. Like this is characteristic of hydrogen. Like no other elements are going to give these exact bands of light coming from hydrogen or coming from the visible spectrum. So we can see that the light emitted from a discharge tube containing hydrogen is analysed using a spectroscope, and a series of coloured lines of definite wavelength against a background is observed. And that's what we have here. We have these definite bands of light are being produced by the hydrogen against this background. So this here is what's known as a line spectrum or an emission. So the emission spectra. So that's like, imagine this is your atom of hydrogen, and you have energy coming in. So it's given off this light. Okay, and this light that it's given off it doesn't contain all of the wavelengths of light like white light does. It contains only some of the elements of light. And then what happens is you pass it through a prism like this, and then it splits it up into these characteristic lines that we see here. So the emission spectra for other elements are also line spectra. The emission spectrum of an element is characteristic of the element and is different from that of any other element. So we can say here that each element will give off a characteristic emission spectra. So we call them emission spectra. Okay, or another way to think about it is they give off characteristic light that's characteristic of them. So like what we see here, we have sodium, it gives off that characteristic yellow colored light. And then if we shine that light onto a black or dark background, we can get these things here, which are known as line spectrums. And these line spectrums are characteristic of each individual element. So we can see down here that we have, so this here is a line spectrum for helium. So we have helium. Again, remember helium is an element that's on the periodic table. That's helium, and this is hydrogen here. And we can see that, when we look at the two of them and we compare them, they have some similar bands. Okay, and they're not exactly alike, but helium, as we can see here, has this characteristic band. It's coming from this wavelength of light in around the yellow region, which hydrogen does not. So helium has it and hydrogen has it. Also as well, you can see here that helium has some of the characteristic green light here, whereas hydrogen doesn't have that. So it's just a quick introduction into this idea of what is known as emission and absorption of light by elements. So what not only do particular elements give off specific wavelengths of light when they're energized, but specific elements, and we look at this in the next lesson, they also absorb certain wavelengths of light, and that's what we'll start to look at in the next lesson. So that is what we mean. So just a couple of things, it's important that you know like what a spectroscope is, and that you understand this kind of a setup here as well, and like what these are. They're line spectra. So thank you for listening, and hopefully that makes sense, and I will see you in the next lesson.